Okay, it's recording. Okay, good morning, everyone. So today we're going to discuss about the third lecture in our course, Artificial Intelligence and Machine Learning for Engineers. This is the third topic that we discuss in this class called decision trees. In the previous meeting, we discussed about polynomial regression, and we have given you I have given you a lab exercise to do manual computation as well as programs to programming exercises for you to do and submit. So just to recap about polynomial regression, we say that it is about uh, an estimation, a way that we estimate a function. For a function, for example, we are familiar that a function called y is equal to f of x, where f is a function. You have an input x, and it will give us the output. This function will give us the output y. So the idea then for polynomial regression is for us to estimate what kind of function, given the inputs, that will best give us an approximate of the data. For example, in the case here, you are given the data of x inputs. This is the x, and these are the values of the x and the corresponding points x and the target. Oh, this meeting will end in 10 minutes. I'm late. Okay. So 11:19. Okay, anyway, I will continue. And then I will give you another link afterwards we'll just continue. Yeah, whenever this one stops, I will keep on giving you a link in Zoom for us to continue. Okay, so now the data x and t. Okay, x is the values along along this axis in the graph, and t are the target values. And so there's a pair of information where you have at each point defined by the x as well as the target value t, the input value x and target value t. And so in this case, I think we have 10 points. And so these data are given. Okay. And then what we need to do is we want to estimate what kind of function that can best fit in this kind of data. And we know that the data, the function is the data is generated by giving some noise to a sinusoidal function. Okay. But of course, we don't, the way we estimate our function is based on a polynomial function. We don't do, we want to do a sine function, the exact sine function, but we want to estimate it using the polynomial function. In this case, we have W0 x to the 0, which is 1, x to the 0 is 1 all the time, plus W1 x to the 1, plus W2 x squared, and so on, plus Wm x to the m, where m is the order of your function. Now, this given x, and then it gives us the output of the function, that of this polynomial function that we try to use in order to estimate the value of y. Okay, so now our idea then, the idea then is to find this polynomial function where we define what are our coefficients w1, w0, wn, w2 up to wm, that will give us a good estimate of y output, so that this y output uh, compared to our target value, which is considered to be our error on the estimate, will be minimal. Okay, so the question is, how do we find those weights w0, w and w2 that will define our polynomial, such that the resulting value of y computed from the polynomial, and then compare it with the value of the target value, will give us a minimum error. Okay, and the way to do it, we have already discussed it in class, that we use the gradient descent method in order to find iteratively the value of the W of the weights. Okay, you have any questions with that? We can discuss. Do you have any questions? on the previous linear regression discussion? If not, then I will continue. So, continue next. So this lecture is about decision trees. What is a decision tree? Yeah. A decision tree is a support tool. Again, it's a machine learning tool or artificial intelligence tool that can give us, again, a decision. It will show us a decision given a function. Okay. Decision tree will give us a kind of a function, a different kind of function compared to the linear regression function or the polynomial regression function. But still, the idea is that we are given inputs and then we want to use the function, this time a decision tree function that will help us in making a decision. This function will give us decisions. Okay. So what is a decision tree and how does it look like? Well, it looks like a tree. Okay, it looks like an inverted tree. In fact, uh, that's why it's called a decision tree, where this tree will help us in making decisions. Okay, so we say that it's a tree-like graph for modeling to model or a model for decisions, and then for us to make decisions and their possible consequences, and it can also include outcomes, resource costs, and utility. So uh, depending on what kind of information you're going to include here in your decision tree. So an example of a decision tree, for example, a program of a problem called with a play tennis. It's about we want to play tennis or not, and the condition of the environment, the condition of the weather on that particular day. So this is the decision tree that will look like on that particular problem. So the first node, or here the first node, is called a root node, which is the root of the tree. If you see, it's an inverted tree. Yeah. And then the leaf node is this node where the branches are coming out. That's a leaf node after the root node. And so these connection lines are called the branches. So start with the root node, it branched out to the leaf node, and then another branches. And then finally, the last layer or the lowest layer, because now it's an inverted tree, the lowest layer are the leaves. Okay. So the root node in this case here, they are considered, we have to note that the leaves are the outcomes. Okay. And then the nodes are the criteria to be answered. It is a criteria or a parameter consisting of several things. For example, the criteria or the parameter of outlook, it is consist of three things: sunny, overcast, and rain, which defines the branches. And the wind parameter or the wind node is also, or criterion consists of also two things. In this case, consists of two things: wind is strong and weak, and then the other parameter or criterion, humidity, consists of two things: high and normal. Okay, so thus these nodes are criteria, or these nodes are criteria consisting of other parameters, of many parameters that will help us branch out to to the decision, in this case to the final decision of whether we want to play tennis or not, yes or no decision. Okay, so in this case here, there is this a function, the function of the decision tree, which is defined by this tree, where our inputs are outlook, humidity, and wind. Okay, so based on these parameters that you input, on what kind of outlook you have, on what kind of humidity you have on that particular day, and what kind of wind you have on the particular day, it will help a decision tree function will give us a decision of a yes or no. Okay. Okay. This is just an overall picture of what a decision tree is about. So now, what does this function can represent? How can we represent that particular function? Okay. So now the rest of the discussion will be for us on how we define the decision tree function that will help us find a decision of a yes or no, or some other decisions, good or bad, with depending on what kind of decisions that we want to make for that particular decision tree. So in this case here, the decision trees can represent any function of input attributes. So any attributes that you want, you can make a particular decision. It could, for Boolean functions, that means for yes and no, for zero or one functions, path to leaves gives us the truth table. And you are already you are already familiar with this Boolean arithmetic and Boolean arithmetic that will give us, or Boolean logic that will give us the output of whether the final output is yes or no, or zero or true or false. In this case here, this is an example of a decision tree that corresponds to this Boolean logic of XOR or exclusive OR given the input A. Okay, A can be false and true, and B can be also false and true. So in this case, we are taking the combinations of A XOR with B, given that in a particular case, A is false and B is false, and the XOR of A XOR of B is false. Okay, so we know those logic. Okay, and then if A is false, XOR with B that is true, the result is true. Yeah. So all this, we are familiar with this XOR table, but then the question is, how are we going to make a decision tree so that this kind, all we need to do is go through the tree, and we will come out, we will know whether the XOR is true or false. For